Hey, what's going on today, YouTube? Today I'm going to be showing you how to fine-tune and train IndexTTS2 on other languages. If you don't know what IndexTTS2 is, it is a AI text-to-speech dubbing model that I've shown in previous videos.
Ever since I was rebooted ages ago, something's been bothering me, again and again. But exposing those misgivings would affect my singing. That is why I've kept a lid on those doubts all this time. And it is you who just opened that lid now!
俺は絶対にマイルを死なせない。家に連れて帰る。
なんだって？いやいやいや、任務があるだろう。
任務なんてクソくらい。クソくらいだよルネ。じゃあどうする？言えよ。どうするつもりだ？3人でペインターズを倒すってのか？
And it is really powerful. So I'm going to show how you can do the whole training process to be able to train other languages here. And I know a lot of you guys have requested this, so we're just going to jump straight into it. So we're going to need quite a bit of things today for IndexTTS2 training. Number one, you're going to need an NVIDIA graphics card. Recommend you have at least 8 gigabytes of VRAM in order to do this. Any smaller, you probably won't be able to train it. Highly recommend at least 12 though. But we are going to need many things installed on our computer. So you're going to need Git installed on your computer. So go here, go to download for Windows. All the stuff is going to be down below in the description. So I'll link all of those there. So go into here and install the x64 setup for Git. Go through all of the default options there. You're going to need UV on your computer, UV Astral. So just go to the Windows installation section, copy and paste this command into PowerShell, and that'll get you UV installed on your computer. You are going to need FFmpeg also on your computer. I highly recommend that you just install and put it into your path. What you can do is download this full FFmpeg get full here. And then all you need to do, you'll have something like this, is unzip it. So you can do extract all, or if you have 7z or 7-zip, you can just do extract to the full build folder. That'll bring you a folder here. We'll go into here. And then we need to just take note on where this bin is. Then we can search up environment, which will bring up edit the system environment variables, go into environment variables, go into path, go into edit, click on new, and then we need to copy this address. So just right click, copy, go back into here, new, paste this into there, and that'll put it into your path, so you can access it from anywhere in your command line. And just to make sure you have that installed, you can just type in cmd and you should be able to just type in ffmpeg. If you get something like command not found, you need to try to reinstall it again. If you get something like this, then you are good to go. So we can exit out of that. You're going to need the CUDA Toolkit 12.8. I think you need this, but it's always good to just make sure you have this. So go to Windows, x64, Windows 11, and then exe local. So just go ahead, download this, install it, run through all the local options or default options, and then we should be good to go. And these are some other stuff we'll cover a little bit later. So the first thing that we're going to do after all of those prerequisites is we need a data set. So what I mean by this is before we train IndexTTS2, you need audio files to give the model a basis for what you want to train it with. So for this case, I'm going to be utilizing Spanish. I've already curated a bunch of Spanish samples and we'll be training a IndexTTS2 Spanish model from scratch. So we'll be making that data set here. So this is where Git comes into handy. So we'll just go to the green box here, copy URL to clipboard, navigate to the File Explorer, and go to any folder, really, and then just type in cmd in the address bar. That's going to open up a terminal in that folder, and then we can do git clone, paste that into here. And then all we need to do after that finishes downloading is just change directory into dataset maker, and then just type in ls or just type in dir. You'll see a bunch of other files here. And then all we need to do is type in uv sync, and that's going to get all of the Python stuff that we need built and ready to go inside of this virtual environment. So there we go. Since I already have everything cached locally, for me it's pretty fast. For you guys, it'll probably be like 6 gigabytes of downloads worth in there. Now, there's actually a patch that we need to do before, and do we do anything? So after UV sync, what you want to do is type UV remove, and then if you go into the README of the repository, go down here and copy this Optimum Onyx Run GPU, and then we're just going to paste that into here, and then we just want to do UV add Optimum Onyx GPU, and then what we should try to do is UV run Python, and then we want to copy this line here, paste it into there, and then copy this line here, and then paste it into there, and we want to make sure that it says CUDA execution provider. If not, then it's going to process UVR very, very, very slowly. So what I can now do is just type in UV run Gradio interface. I'm just using tab to finish that up. And what this is going to do is it's going to launch a Gradio interface on local host 7860 that we can go into. So go into here, type in localhost 7860. And once this loads up, then we should be able to see it. So give it a little bit of time to load up, and then it'll be good to go. And so if you get an error like this, it should be fine. For our use case, we're not using libtorch codec here, so we don't really need it. And then after that, we need to do a few more things before we're actually able to use it. So first, go into the not flash attention. We need to get some models for the dataset maker that are compatible with it. So you need to go into this dataset maker HuggingFace page. It'll be linked in the description. Download this UVR MDX net file. So navigate into Dataset Maker and then put this inside of the Amelia_models folder. So save. And then same thing for this SIG-back OVR Onyx. I'm going to go to that same folder, Amelia models, and just go ahead and save that there. So that'll get the models that we need for this. And before you do anything, you're going to need some data. So however you want to curate it, I'm not going to be able to help you guys out with this, but you can download YouTube videos. You can find online data sets for the language. The one that I'm going to be using is this Facebook's Vox Populi data set. And I've already gone ahead and downloaded a bunch of files here for it. So I've got all of those train data sets, or those audio files extracted. And as you can see, got these WAV files. And then with that, we can head over into the Gradio interface. So I'm actually re-recording this. So I've already done everything, but I'm going to go through this with you guys a second time, for me at least. We're going to go into the Gradio interface and make a new project. So I'm going to call this Spanish 2. Create project, and we'll have it successfully created there. Go ahead, click refresh projects, and then we'll select the one that we just made, Spanish 2. And so there are two ways we can upload audio files. One, you can drag and drop them into this upload audios file box, or you can just click it and select the files that you want. Now this works if you have a lot of long audio files, so like 1 to 2 hours long. If not, what I'm going to end up doing is merging all of those into long audio files with this combined small samples tab area. And so I'm going to go with that second option. So for example, I've got 10 folders here with lots of small audio files in them. And all I am going to do is go into the Dataset Maker folder, go to Datasets folder, go into that Spanish 2 project that I made, and then go into this Waves folder. Now what I'm going to do is copy all of these files into there one by one. So copy, select all 5,000, paste. I'm going to do that. Rinse and repeat, go into here, copy all 5,000, and then we're going to paste those into there. So I'm going to do that 10 times and then be back. And then since those are small WAV files, what I want to do is I want to combine all of those small samples. So I'm going to go into here and click on Combine All Samples. and it's going to combine all of those into up to 2-hour-long WAV files. This is to make the transcription process much faster. So I have already done this, and the output for it will be something like this with a bunch of combined WAV files. And so once you have that, it'll move all of those uncombined ones, the raw data, to an uncombined waves folder. So I'm gonna go actually and now select that other folder so we can continue with that. And then we'll go into the transcribe area. So for here, since I'm doing Spanish, I'm gonna select Spanish. For the slicing method, we want to do Amelia pipe. For the batch size, we'll leave at 16, large whisper v3. We want to run UVR separation, so this is going to separate the background noise from audio files. Now, if you actually have access to perfectly separated audio where it's just vocals, no background, go ahead and turn off UVR separation, because if you run it on perfectly separated audio, it could lower the quality, so we'll just turn that off. It'll also make it faster if you run without UVR, but I'm going to go with the assumption that you have not separated the background, so use run UVR separation. Amelia whisper threads, this is how many CPU cores or CPU threads that whisper process is going to use for transcription. So just going to put that at 8, and then minimum segment duration we'll leave at default. For this, I'm going to use file hash naming, and we don't want to keep the processed WAV files unless you do for some reason for debugging purposes, but I'm going to leave this turned off, and it's going to save us a lot of disk space while it's processing. And then for the max segment length, we're going to bring it up to 60, and those should be all of the settings that we need. So what we can do is go ahead and just start new transcription, and it's going to start running here now. So and then we need to set up this Amelia configuration file real quick. So that's good that we have that there. So what you're going to need to do is open up the Dataset Maker root folder, go into Amelia, and then we need to configure this configuration file here. Now, what you end up having, what you're going to need here, what you're going to need here is you're going to need a HuggingFace account so that we can get access to some gated models, and those are going to be necessary for the pipeline. So what you need to do is head over into HuggingFace, create an account, and then go over into this page here. We're going to do the PyEndNote Speaker Diarization Community 1 model, and you're going to need to log in so you get access to this model. So it'll ask you for some information, confirm, and get access to this Community 1 model. And then once that is finished, it should look like something like this, where it says gated, you have been granted access to this model. So once you have that, what we need to do is we need to create an access token. So you can just click on create new token, do read, and then you can name this whatever you want to do. So I'm going to call this test delete me. And so I'm going to create the token, and then I'm going to put it inside of my YAML file. So I'm going to skip this process so you guys don't see it. And so you go back into that configuration file, and you're going to paste it into here. So whatever it is, you're going to paste it in there. So once you have that done, what you need to do then is just rename this to config, and we should be good to go. So your file should be in there, or your HuggingFace token should be in there, and then we can head back over into the interface and then click on start new transcription. So we're gonna go and monitor in here, but what's gonna happen is it's going to download all of the models that we need. So this is going to take a little bit of time, and if you're curious where it's downloading the models to, it's outputting into this Amelia folder here. We got Whisper, and then we'll have PyEndNote. So let those finish up, and we'll be back. Okay, so this messed up on me last night while it was processing because I ran out of space. So I'm just going to use what I have right now, which is a lot of data. We'll go into the datasets folder. That's where you'll find it, the Spanish one, and then the Spanish_Amelia dataset. If we go into here, I've got a bunch of data processed, probably about 45K samples here. And that should be good enough to go to get started for the run. So I am actually just going to close out of the current run that I have here. This is what I had restarted up after, or this morning when I woke up. So I'm going to close out of that. and we should be good to go and start getting IndexTTS installed, and we'll go ahead and do that. So you should now have a data set that you can use for IndexTTS 2. And so the repo that we're going to be using is this training folder or this training GitHub here. So head on over, go into this green button, go to copy a URL clipboard, and then we'll go straight into that directory. Or if we go back into the file explorer, go to whatever directory you want to do, just do cmd, and that's going to bring us a terminal here. We can do git clone, paste that into here, and then what we can do is cd into IndexTTS and do dir, and we should have a bunch of files here. You are also able to go and double click into here, and we should be good to get started on some of the things that we need to get done. So for checkpoints, we're gonna need all of the IndexTTS 2 models. So the easiest way to do that is to use HuggingFace in order to do so. But we're going to want to get our UV, our virtual environment for Python, all set up in this repository. So what we need to do is, once again, open up that terminal window. I'm going to do CLS to clear. And what we need to do is git fetch, to fetch all of the branches. And then we need to do git checkout, or git switch, I think it's checkout, training underscore v2. And so that's going to move our code base over to the version 2 of the branch, which has all of the training stuff that we need. And then what we can do is type in UV. Oh, actually, before we do UV sync, what we're going to need to do is install some wheels. And so if you head over into the Hugging Face repository, what we need are these flash attention wheels. And so we'll need this one right here, which is this bottom one. So download, and then we're going to put it inside of the IndexTTS2 root directory. And then we'll navigate back into here. And I just want to check one thing just to make sure that the names do indeed match. So just to be safe, what we're going to do here is we're going to rename that wheels file that we downloaded just to make sure we have all of the correct wording. So just go ahead, select that, copy, and then we'll navigate back into the folder. Go ahead and right click, rename, and then paste that into there to make sure that we have the correct name there. So that should be all we need to have to get up and going. Then we just do UV sync. Oh, I messed up here. So make sure it's not .wheel. Make sure it's just .whl at the end there. And then we should be able to do UV sync. And so that's going to build everything that we need, get everything installed, and we are going to be good to go there. So once again, I have everything pre-cached here, so it's going to go pretty fast for me, but for you guys, it might take a little bit longer. Okay, so now that we have everything good to go, we're going to move that data set that we have from the maker into IndexTTS2. So I'm going to go back into dataset maker, datasets folder, Spanish. I'm going to go to that Emilia dataset. For me, I'm just going to cut, and then we'll go back into IndexTTS. And then what I'm going to do is just create a new folder called datasets. It doesn't really matter what you name it, just doing this for bookkeeping, and then we'll paste that into here. So we have this Spanish dataset here. And we need this JSON L file in order to do a couple of things. So now that we've got the data set moved over, let's go ahead and get some of the models. So if we go back into the repository, we'll go ahead and just do this Hugging Face download, go back here. This is the terminal window, and then we'll just paste that into here. Sorry, we'll have to do UV run HF download. And so what this is going to do is it's going to download all of those files that we need. What I'm going to do is just move it over from another repository because I already have them all downloaded so that it doesn't take me the extra time. But you'll just have to wait for these to finish up. And after it finishes downloading, if you go into the checkpoints folder, it should look something like this. Key points is make sure your gpt.pth is about 3 gigs. And then your BPH or your BPE model is about 465 kilobytes. So we have our models, and what we need to now do are some processes to enable IndexTTS2 to be able to use our data set. So what we want to do is we want to extend the tokenizer. And for IndexTTS2, it might be possible that your data is already covered inside of the tokenizer if you're using something like English or something that shares English tokens, but most likely you're going to want to extend it. So now in the repo, I have this extend bpe.bat that we can use. And so we pop it open here, and well, inside of that terminal, we'll do cmd here. All we need to do is modify some of these parameters, and then we can pass it. So for this, leave these first two lines the same. And then for the data set, we're just going to need to build the path there. So from the root directory, it's inside of datasets. So we can type that in datasets / Spanish Amelia dataset. We can just copy and paste that here / and then we'll double click into here. And then we need this JSON-L file. So copy and paste that into here. And that should be it for this extend bpe.bat that we need. Target size, we are going to aim for double the size of the original tokenizer. The original tokenizer is 12,000, and then we want 100% character coverage. So we can go ahead and copy and paste this into here. Now, note if you're on PowerShell or anything like that, you need to actually just use these backticks instead of these carets. But since we are doing this in the CMD, just going to put those back, and we'll just copy and then paste. So go ahead, paste that into here, enter. And now this is going to start running through the entire process for extending the tokenizer. And so we'll just wait for this to finish up. And so it finishes up here. You can see that it appended 12,000 new tokens for a total of 24,000. And then we can just take a look at it real quick. So we actually have it dumped to this, let's see, where's it dumped out to? Checkpoints. Oh, here it is. This .vocab file. And what we could do is just right click, edit in Notepad, and we can see all of the different tokens that are in here. So we're going to go past 12,000. And then we can start seeing things that are in Spanish here. So we should be good to start training on that. So I'm going to close out of those guys there. And that is how we extend the tokenizer. Now, the next thing we need to do is pre-process all of our data sets to be ready for IndexTTS 2. And so let's go into the, preprocess _ batch file. We'll go into edit here, and we're going to do the same thing. So for the manifests data set, for the manifests here, we're going to do the same directory. So once again, in that datasets folder, this Spanish Amelia dataset, I'm going to / here, and then that JSON-L file, once again, I'm going to go ahead and / put that into there. So, oops, sorry, I had it in the wrong spot, so paste that there. And then for the output directory here, I am going to rename this to ES processed data, or let's just do Spanish processed data. So we'll leave that there, take away that /. And then the tokenizer we're going to use is, if we go into checkpoints, we want to use this extended bpe.model. So we'll go ahead and copy this into here. And then we'll just replace this with that tokenizer. So checkpoints / extended bp tokenizer. And then the configuration we're going to leave for this config finetune.yaml. The GPT checkpoints, we are going to copy this gpt.pth and replace this there. So that's the one that we want to process from. And then the language, we are going to do Spanish. So use the 2-digit code for whatever your language is. We have this ES for Spanish here, CUDA for NVIDIA, batch size 1, workers 1, and number of processes 1. So recommend you do those, and then just leave launch delay there, skip existing, and then validation ratio we'll leave there too. So once again, we're going to copy this, but I'm going to replace all of these with these up carets since we're using the CMD terminal. And then we'll go ahead, copy these, and then we'll paste this into here. So now this process is going to take a decent amount of time depending on how much audio you have to process. So for me, this is going to process probably around 10 samples a second. And so if you just do the math on that, it can take a long time. For example, for 6,000 hours of audio, it took me about 2 days to process. So we're going to let this pre-process, and then we'll be back once that is finished up. Also, note that some things are going to download during the process in order to do all the pre-processing that is necessary. So you might see that start happening in the terminal. And now once pre-processing is done, we can start getting the data ready to start training. And we'll go ahead and set that up now too. So there are a couple of other batch files we're going to use. So go into the root directory, and we want to find this pair.jsonl.bat. And so what we're going to do is just right click and click edit. And it's going to open up this file right here. So all we need to do is just point this to that directory that we had inside of the root folder. So the dataset I'm using is the Spanish process data. So you can just copy the name of it and paste this after dataset. So it's right there. And then for my data set, I'm going to do 2 pairs per target. So to give myself a little bit more data, and then this force command here. And then we're just going to copy this into here, jump it into the terminal, and then paste this. And you might have backticks here. Backticks look like this. So what you need to do is, remember, just replace them with the up caret here. That's because I was running things in PowerShell earlier. And then once that is done, we're going to head into the folder just to double check that they are there. So now we have this GPT pairs JSON-L file that we're going to use for training. And then inside of train.bat, we're going to need to set this up. So I'm going to close mine out. And then if you go into the root directory, just go ahead, right click and do edit. So what we're going to need to do is change a few things in here. Now your guys's might look a little different and might actually look like this. So I'll just edit it from this one. So yours might end up looking like this, and we're going to just have to set it up from here. So go ahead and delete 4 of these train manifests and then 4 of these val manifests. That was only if I wanted to use multiple different data sets to train the model. And then we're going to set this up here. So inside of train manifest, we just want to find where our JSON-L file is for the train pair. And that is located at Spanish process data / GPT pairs train JSON-L. So we can just delete this, type in that Spanish. Yeah, I'm just going to, what I like to do, I just like to go out, copy, paste that here, and then we'll go into it. And then we'll just copy the name of the file. We're going to do / here, paste that in there, .jsonl. And then for the val manifest, let's just copy this top line here and then paste that in the val manifest. And then we're just going to change this to val. So now we've got the train and then the validation. And then the tokenizer is going to point to the new tokenizer that we have. So that is this extended BPE model that we have. So just copy that, remove BPE model, paste that extended BPE, name it model, or dot, make sure it has that dot model at the end there. Leave the configuration there. For base checkpoint, we're going to change to checkpoint / GPT.pth. So that's going to be the base that we use. And then for the output directory, you can name anything. I'm just going to remove this train checkpoints Spanish. I'll call this 2 because I've already done a training. And then for batch size, I recommend that you use 1 batch size per, or for every batch size you use, it's going to take roughly about like 4 gigabytes of VRAM. So if you have a 12 gigabyte card, I would recommend you put this at 2. If you got a 16 gigabyte card, put it at 3, 24, put it at 4, 5, or 6-ish. So you can play around with this batch size just to see what works for your GPU. But I'm going to leave mine at 24. Gradient accumulation, I'm going to leave at 1. Epochs, this is how many times you want it to train on the data set. So we're just going to do 2, leave it at default. And then everything else here, we can leave pretty much the same. Now for validation interval, I'm actually going to change to 1000 just so it does validation a lot quicker. So once we have this, we should be good to go to start training. And so what we could do is just copy and paste this. But I actually have to change all these backticks to up carets now to So we just replaced all those with those up carrots. And so up carrots or up arrows. I just realized I've been saying carrots. And then we're just gonna copy and paste this into the terminal. So you don't have to do that replacement if you're running in PowerShell, but since we're inside of just the CMD, we do. So we're gonna paste that into here, and it'll start training. So training more or less is going to take a very long time depending on your GPU. Now I've already done a complete training, and I just went over the steps again right now, but if we take a look inside of the index folder at the root here, I already have a trained model for Spanish. So here we go. But yeah, it's going to take quite a bit of time for you to finish this up. And so I got this error here. Oh, I have a typo. So checkpoints, plural. So I'll paste that back in here. So typo. And then training will start going. So yeah, you'll notice this is starting to happen. It's going to process all of the data. And this means that training is now running. So cool. You just let it run, sit there, go do something else, and come back once it's finished. So I'm going to cancel this out. So let's say that training has finished for you. We just want to look at how the training did. So what we can do here is I'm going to type in CLS to clear. UV run tensorboard --logdir, and then we're going to name that folder that we outputted the models to, trained checkpoints Spanish. And so what this is going to do is it's going to launch tensorboard so that we can look at how the training progressed during kind of the process. And then we go into our browser, localhost the :6006, and that'll pull up these nice little graphs that we have here. And so I like to do smoothing to the maximum or close to the maximum so that we can kind of see the general trend. And what you should notice is the loss should be going down and then flatten out at the end. So we've got our mel top. Mel top is going to keep going up. Text loss should continue going down. It should average out around 1.5 for text loss. And then for the same thing, you should notice inside of the validation. So these are kind of how the curves look. And then, so inside of training, it only saves the last 3 epochs of training. So 38K, 39K, and then the last one. So if you want to save anything earlier, you'll have to do that manually. I'm doing this because of space requirements, because each one is 7 gigs. And so once that is finished, once training is finished, we can now use it. So I'm going to Control-C to get out of there. And what we need to now do is prune the model. I recommend that you prune the model. It's going to remove all of the training keys so that we just have the inference keys inside of the weight, so the inference weights only. And the script that we go to is this prune model.bat1, and it looks like it's empty, so I'll have to I'll push that to the repo to make sure it's not empty. But what it should look like for you guys is like this. And so what we are going to do is just point this inputs directory to the Spanish one. So what I'm going to do is just type in Spanish, and then the latest Spanish model that we had was this 39002. And so we can just copy this / paste that in .pth. And then the name for it, we are going to do Spanish 39K. And then we'll just copy this, paste this into the terminal. Oops. And we need to go back to the up arrows because PowerShell, and then paste that into here. And this should finish up pretty quick. So there we have right there. And then where it goes is inside of this models folder in the root, and you'll see that it's here. So cool. We've got everything that we need. We've done training. We've trained quite a bit on this model, and then we can go ahead and launch our web UI to test it out. So what we're going to do is type in UV run web. I'm going to use tab to finish. And then we want this web UI parallel.py. Go ahead and run that. And what that's going to do is output it to localhost 7862. So we'll go into here and you'll see that it's running on this URL. So what we can do is localhost 7862. And that's going to launch the IndexTTS parallel demo. And we just want to select the Spanish one that we have here. The extended BPE.model that we had. You could actually rename it to whatever language, like Spanish if you wanted to. And then we're going to click on load models here. And if you look inside the terminal, you might see something like this. This is just reshaping some of the parameters that are hard-coded or coded into the defaults for the GPT model. And it should say models loaded successfully up here at the top. And so what we can do now is inference on the model. So I'm just going to click one of these example texts down here. These are provided with the repo. And I just want to input some type of text in here. And so what I can do is go into my Spanish to process data, go into the val manifest.jsonl, and then just find any random sentence in here to inference on. And so we'll go ahead and just copy this one here, and then we'll paste this there, and then make sure match prompt audio is selected. Then we'll click on generate and go back into the terminal to see what's happening. So you'll see something like this, and then it'll start doing the generation. And there we go. We've got it done. And then we can take a listen to it. So here we go.
Es un universo comprensivo de distintas medidas y recomendaciones, pero que a su vez tienen hojas de ruta distintas.
Alrighty, so there you go. I think that spoke Spanish. I don't know how well it spoke Spanish, but it did it. And the initial input here is in Chinese. So this is the input.
公贵森严，几个人不得信口雌黄。
So I can probably even try this on my own voice. And my recording got corrupted, so here I am again with the recorded voice. Hello, testing my voice here in the Gradio interface. And then this is the generation.
Es un universo comprensivo de distintas medidas y recomendaciones, pero que a su vez tienen hojas de ruta distintas.
Okay, so there you go. There is my voice. That is Spanish indeed. And then there are some settings that you can change here. The biggest one I think for you guys is going to be seed. So seed just makes it very deterministic. So if I have the same seed, every time I generate on that same sentence, it's going to reproduce the same output. And so if you want different styles of that sentence, you're going to have to change the seed like 1, 2, 3, 4, 5, 6, whatever number, as long as it's different. And then like some of these other ones, like temperature changes how random it is. I just tend to leave all these at default values, but you're free to play with those too. Now, this target duration seconds is still kind of broken. It's just an experimental setting here. So nothing to really go over with that too much because it's not officially supported. Yeah, real quick, I want to show how you can resume a training in case maybe something failed or something got messed up. So what we want to do is actually let's open up that train.bat script one more time. I right-click edit. What we want to do is locate where we have the trained .pth files already. Let's say I want to restart from here or from here. I just need to copy the name of this file. And for the base checkpoint, what I'm going to do here is delete this. I'm going to type in the name, which is train_checkpoints Spanish here. / and then the name of the model here. So that's this folder plus the model here. And then what I want to add is another up arrow there, 2 dashes, resume, and then type auto. So resume auto. And so what that's going to do is it's going to resume the model training from this point. And all we'd have to end up doing now is I'll go ahead and just output to the same folder. What we can do here now is just go ahead and launch training one more time, and I'll show you guys that it starts up from that 38,000 mic point. So, all right, so here you can see it loaded everything up, and it actually training is complete because I have this set at 2 epochs. and this was at the 9th epoch. So if you want to continue training for a longer amount, you just increase it. And then likewise, if you want to restart training, just instead of setting the base model to .gpt, you just set the previous models that you trained with, remove, resume auto, and it'll restart training from scratch. So yeah, that's going to be it for today's video on how you can get IndexTTS 2 training. Now, there are still a lot of things I'm investigating personally, so it's not a fully fleshed out pipeline, and I don't know all of the answers, so there's going to be a bunch of questions for me to find out and things to investigate. But yeah, if you want access to the Spanish model that I trained in today's video, if you're a member of the channel, you'll get access to it in the members post area. So just go check that out after the video. And I'll have the tokenizer and then the model uploaded in there too. So you could use those. And for the most part, yeah, that's going to be it. Once again, I'd like to thank all the members of the channel for supporting me, and I very much appreciate it. So I will see all of you guys